So, I want to ask you a question today. How? It is a question that sounds very simple. It sounds like a question a 5-year-old child would ask his mother. The question is this: why is the night sky dark? Now, you are going to laugh at me. You are going to say, Professor Feynman, that is a stupid question. You are going to say, it is dark because the sun has gone down. The earth has turned round and the sun is on the other side, and so there is no light. And I am going to tell you that you are wrong. Well, you are partially right. That explains why it is not daytime. That explains why we are in the shadow of the earth. But it does not explain why the sky itself is black. Think about it, you know. If you go out into the deep ocean and you look at the water, it is dark. But if you look at the sun, it is bright. Now imagine the universe for hundreds of years. The astronomers and the philosophers believed something very specific about our universe. They believed two things. First, they believed the universe is infinite. It goes on forever in every direction. Left, right, up, down. It never ends. Second, they believe that the universe is filled with stars more or less evenly like raisins in a pudding. Sure, they clump together in galaxies, but on the big scale, they are sprinkled everywhere. So, we have an infinite universe, and we have an infinite number of stars. Now, I want you to do a little experiment in your head. I want you to imagine you're standing in the middle of a forest. A very thick forest. Everywhere you look, you see trees. Now, if the forest is small, you can look between the tree trunks and you can see the sky outside and you can see the gaps. But suppose the forest is not small. Suppose the forest is infinite. Suppose the woods go on forever and ever. Now, look horizontally, look straight ahead. Your line of sight hits a tree trunk. Now move your eye a tiny bit to the right. You look past that first tree. But because the forest goes on forever, eventually your line of sight hits another tree trunk further back. Move your eye again. You miss the first tree. You miss the second tree. But 10 miles away, you hit a third tree. If the forest is truly infinite, then no matter where you look, you must eventually hit a tree. There are no gaps. The entire horizon is made of wood. It is a solid wall of trees. Do you see the geometry? It is unavoidable. Now, I want you to take that forest, and I want you to replace the white tree trunks with bright yellow. Stars, look at the night sky. Pick a spot. Any spot, a dark patch between the constellation of Orion and the Big Dipper. It looks black. But why is it black if the universe is infinite? Then, if you look at that dark spot, your line of sight goes out into space. It goes past the moon. It goes past the planets. It goes past the local stars. But if you keep going, eventually you must hit a star. If the universe is infinite, every single line of sight from your eye must end on the surface of a burning star. Every single point in the sky should be filled with light. You should not see any black. You should not see any dark patches. The entire dome of the night sky should be a solid sheet of light. It should be glowing with the same brightness as the surface of the sun. This is not just a guess. This is a mathematical certainty based on the assumptions we made. If the universe is infinite and static, the night sky should be blindingly white. It should be so bright that it would boil the oceans. It should be so bright that life on Earth would be impossible. But you look up, and what do you see? You see darkness. You see a few tiny pin pricks of light and a whole lot of nothing. This contradiction is called paradox. It is named after Heinrich Ohlers, who talked about it in the year 1823. But it is a problem that goes back much further. It is a problem that worried Kepler. It is a problem that worried Halley. It is a terrible problem because it tells us that one of our fundamental assumptions about the universe is wrong. Nature is telling us something. She is shouting at us. She is saying, "Look at the dark. The dark means something. The dark tells us that the universe cannot be infinite and old and static all at the same time." Now, you might sit there and you might try to wiggle out of it. You might say, "Well, Professor, maybe the stars far away are dimmer. Maybe the light gets tired. Maybe the light fades out before it gets to us. We call this the inverse square law. We know this law. If you move a light twice as far away, it looks 1/4 as bright. So you say clearly, the distant stars are just too dim to see it. And I say to you, no. That does not save you. That does not solve the problem. Let me explain why with a little bit of geometry. Imagine we draw a shell round the Earth like the skin of an onion, a big sphere of spade. Let us say this shell is 1 billion miles away, and let us say there are 10 stars in this shell. They give us a certain amount of light. Now let us go out, twice as far, 2 billion miles away. We draw a second shell because the stars are twice as far away. Each individual star is 4 times dimmer. That is true. But because the shell is twice as big away, it has 4 times the surface area. So it holds 4 times as many stars. Do you see what happens? The stars are 4 times dimmer. But there are 4 times as many of them. 4 asterisk 1/4 equals 1. The total amount of light from the second shell is exactly the same as the total amount of light from the first shell. This works for the third shell and the fourth shell and the millionth shell. Each layer of the universe adds the exact same amount of light to our sky. And if the universe is infinite, then we have an infinite number of layers, and we add up an infinite amount of light. So the dimming does not matter. The geometry cancels it out. So we are stuck. We are really stuck. We have a logical proof that the sky should be on fire, and we have the observation that the sky is black. This means that something in our idea of the universe is broken. Is the universe not infinite? Does it have an edge? Is the universe empty? Is the dust blocking the light, or is it something much more strange? Something to do with time itself. To find the answer, we have to stop looking at the stars and we have to start thinking about the history of the universe. We have to realize that looking out into space is exactly the same thing as looking back in time. And that is where the secret of the dark sky is hiding. Now I look at your faces and I see that you are not satisfied. You are sitting there and you are shaking your heads and you are thinking to yourselves, Professor Feynman is trying to pull a fast one on us. You are thinking, sure, if I look at a forest, the trees block my view, but stars are not trees, stars are the lights. And we all know from our own experience that lights get dimmer when they move away. If I hold a candle right in front of your nose, it is bright. It hurts your eyes. But if I take that candle and I walk a mile away, you cannot even see it. It becomes invisible. So you are thinking that the stars very far away are just too faint to matter. You think they are so dim that they do not add up to anything. And that sounds like common sense. But I have to tell you that in physics, common sense is often the enemy of the truth. So let us not guess. Let us not use our intuition. Let us calculate. Let us do the arithmetic. We have a law in physics called the inverse square law. It is a very precise law that tells us exactly how light fades with distance. It says that if you double the distance, the light does not go down by half. It goes down by a factor of 4. 2 multiplied by 2 is 4. If you triple the distance, the light goes down by a factor of 9. 3 is 9. So mathematically we say the brightness is proportional to 1, the distance squared. So you say, see, I told you the stars far away are incredibly dim. A star that is 10 times farther away is 100 times dimmer, so the background stars must be invisible. But you are forgetting the other half of the story. You are forgetting that space is three-dimensional. You are forgetting that as we look further out, the volume of space gets bigger. I want you to imagine that we are building a model of the universe using shells like the layers of an onion. We put the Earth in the center. Now imagine a shell of space that is exactly 1 unit thick, and it is at a certain distance. Let us call this distance r. In this shell there are a certain number of stars. Let us say there are 1,000 stars. Now let us go out to a second shell. This shell is at distance 2. It is twice as far away each. Now we ask 2 questions. Question 1. How bright is the average star in this second shell? Well, we use our inverse square law. Since the distance is double, the brightness is 1/2 to that is 14. So, the stars are 4 times dimmer. Question 2. How many stars are in this second shell? This is just geometry. The surface area of a sphere is 4 multiplied by pi multiplied by the radius squared. If you double the radius, the area does not double. The area quadruples. 22 is 4. So the second shell is 4 times bigger than the first shell if the stars are scattered evenly through space. Then the second shell must contain 4 times as many stars. Now look at what happens when we combine these 2 facts. We have 4 times as many stars, but each star is 1/4 as bright. What is 4 multiplied by 1/4? It is 1. The number 4 on the top cancels out the number 4 on the bottom. The dimming effect is completely destroyed by the fact that there are more stars. The total light coming from the second shell is exactly the same as the total light coming from the first shell. Now let us go out to a shell that is 10 times away. The stars are 100 times dimmer. 110 squared. But the shell is 100 times bigger. 10 squared. 100 multiplied by 1. 100th is still 1. It is a constant. It does not matter how far away you go, and it does not matter if the shell is 1 billion or light years away. And the light arriving at your eye from that shell is exactly equal to the light from the nearest shell. This is the terrible secret of the geometry. Now we have to add it all up. To find the total brightness of the night sky, we'd have to add the light from the first shell plus of the light from the second shell plus the light from the third shell, and so on forever. If the universe is infinite, then we have an infinite number of shells. We are adding the number 1 plus the number 1 plus the number 1 plus the number 1 infinite numbers of times. What is the sum of that series? It is infinity. The arithmetic tells us that the sky should not just be bright. It should be infinitely bright. Now in the real world, stars are not points. They have a size. They block the stars behind them, so the brightness cannot go to infinity, but it will go up to the maximum possible brightness. It means that every single line of sight leaves your eye and eventually hits the surface of a star. If you look at the sky, you are looking at a wall of star surface. It means the night sky should look exactly like the surface of the sun. The average temperature of the sun is 5,000. So the temperature of the skies should be 5,000. Earth would be inside an oven. The oceans would boil away in seconds. Rocks would melt. Life would never begin. This is the conclusion of the geometry. If the universe is infinite and if the stars go on forever and if the universe has existed forever, then there is no escape from the heat. The fact that we are here, the fact that you are sitting in a cool room, the fact that the night is black and cold, this is proof. It is absolute proof that one of our assumptions is wrong. It is not a maybe. It is a certainty. The darkness of the night is screaming at us that the universe is not what we thought it was. So what is wrong? Is there something blocking the light? Is there a fog in space? Or is the universe not infinite? Or maybe, just maybe, the universe has not been here forever. Because if the universe had a beginning, then the light from the distant shells has not had time to get here yet. We are waiting for the mail to arrive. But before we get to the true answer, we have to talk about the answer that everyone believed for 100 years. We have to talk about the dust. So we are in a mess. We have calculated that the sky should be a blazing wall of fire. But we look up and it is dark. Now, when scientists run into a problem like this, the first thing they do is look for a simple way out. They look for something obvious that they might have missed, and for a long time. Everyone thought they had found the answer. For almost 100 years, astronomers said the answer is dust. It makes perfect sense to your intuition. However, imagine you are driving your car in a heavy fog. Can you see the headlights of a car that is a mile away? So, no, you cannot. The water droplets in the air catch the light and they scatter it or they absorb it. The light stops. The fog blocks the view. We know that space is not empty. It is dirty. It is full of gas. It is full of dust clouds. It is full of junk left over from exploded stars. So the astronomer said, aha, the universe is infinite and there are infinite stars. But we cannot see the distant ones because there is dust in the way. The light hits a cloud of dust and it gets absorbed. Problem solved. Everyone can go home and sleep. But there is a catch. There is a law in physics that you can never break. You can try to cheat it, but it will always catch you in the end. It is called the law of conservation of energy. It says that energy cannot be created and it cannot be destroyed. It can only change form. So think about the photon of light leaving that distant star. It carries energy. It hits a particle of dust. You say the light stopped. Okay, but where did the energy go? It did not vanish. It went into the dust. When the dust particle absorbs the light, it gets excited. It jiggles. It gets hot. Now imagine this dust particle sitting there in space for millions and billions of years. It is constantly being bombarded by light from all sides. It is absorbing more and more energy every single second. As it absorbs energy, its temperature goes up. And about what happens when things get hot. They radiate. They glow. If you take a piece of iron and you stick it in a blacksmith's forge, it starts out black, but as it absorbs the heat from the fire, it turns red, then it turns orange. And finally it turns white hot, and here is the rule of thermodynamics. The iron will keep getting hotter until it is exactly the same temperature as the fire on it. It reaches equilibrium. At that point, it is giving off just as much light as it is taking in. So, let us go back to our dust cloud in space. If the universe is old and infinite, that dust has been sitting there for an infinite amount of time absorbing an infinite amount of starlight. It will heat up. It will get hotter and hotter. It will stop heating up only when it glows just as bright as the stars that are shining on it. So what would you see from Earth? You would look up and you would not see the distant stars. That is true. But you would see the dust, and the dust would be glowing with the same intensity as the surface of a star. The wall of stars would simply be replaced by a wall of glowing dust. It would be like trying to block the sun with a blanket. But the blanket gets so hot that it catches fire and glows just as bright as the sun. You are still dead. You are still bold alive. So the dust theory fails. It fails completely. It fails because you cannot hide energy. You can move it around and you can turn it from light into heat and back into. It was proposed by a man named Carl Charlier about 100 years ago. Mathematically, it works perfectly. It solves the paradox without any magic. But there is a problem. Physics is not just about writing down beautiful mathematics. Physics is about checking with Mother Nature to see if she agrees. We cannot just sit in our armchairs and guess how the universe is ranged. We have to look. So astronomers have spent the last 50 years mapping the sky. They count the galaxies. They measure where they are. They make giant three-dimensional maps of the universe. And what do they find? They find that you are right, but only at the small scales, yes. Stars clump into galaxy. Yes, galaxies clump. Interclustered. Yes, clusters clump into supercluster. But once you get to a certain size, once you look at a box of space that is about 300 million light-years across, the clumping stops. The hierarchy ends. On the truly large scales, the universe is smooth. It is a homogeneous. That is the word we use. Think of it like a bowl of porridge or oatmeal. If you put your face right down in the bowl and look with a microscope, you see lumps, you see oats, you see milk, you see empty spaces. It looks complicated and clumpy. But if you stand back 10 feet and look at the bowl, it just looks like a smooth gray paste. It looks the same everywhere. The universe is exactly like that porridge. If we look at the universe on the scale of millions of light-years, it is a mess of webs and voids. But when we look at the universe on the scale of billions of light-years, it is remarkably boring. It is the same everywhere. The density of stars over here is exactly the same as the density